Hello and good evening. Welcome to this room. Sorry for being late. It's not really easy to organize this conference in such a short time, but it was a collaborative effort of the Arduino community. We are very happy to make this happen. We are very happy to have all of you here. So this track is about Arduino-based medical devices, which are not ventilators. If you're interested in ventilators, you can join room 1. You will find the YouTube link on the conference page. While in this Zoom room, we are going to talk about all the other kind of devices which are potentially useful for combating the COVID-19 pandemic. We know that ventilators are a very important device. We also know that the medical community and other communities need so many other devices, and potentially they might also need something that hasn't invented yet. So we got a number of applications in the past few days, and speakers are in this room. So I would like to start quickly so that we don't waste our time. And I would like to ask the first speaker to present their project, Youseff Muhammad. I will give you the ability to talk. Youseff Muhammad from Cameroon. The project is about the design of an oxygen concentrator based on Arduino. Youseff? Okay, let's try with another speaker. Rohit Sharma, are you there? Rohit Sharma from the United States.
Yes. Can you hear me?
Yeah, we can hear very well. Welcome.
Thank you. So let me share the PowerPoint quickly, and I have 5 minutes, I assume. Can you guys see my screen?
Yeah, we can see your screen.
Okay, wonderful. So my name is Rohit Sharma, and I work for AITS. And our project is Arduino AI toolchain. What we offer is software and set of algorithms that make it easy for your AI algorithms to quickly deploy on Arduino devices. And in the times of need, we are offering our services for free. For anybody who needs, we are ready to join hands on COVID-19 apps. We are looking to collaborate with you. If you have an idea with passion, be it a doctor, an academician, a professional, a company, researcher, or an innovator. We will provide all the softwares, access to our data scientists, embedded professionals, guidance on firmware, hardware, and technology, and ongoing help in the development and debugging of the application. Please do join hand with us. We are looking to help you develop your application. So how is our platform helps you? One of the ideas, COVID ideas is ventilator components. You can use AI to build flow analyzer, ventilator testers, monitors, and so on and so forth. And the ideas have to come from you. We would provide all the help, the data that you would need, the software that is required, and everything to help you build the entire application. And so in detail, what do we provide? We help you with picking up the software. We do supply software setup. We would help you with acquiring the data, train the model, develop the application, compile the application, and flash the application, and also monitor the devices. Everything around Arduino is our expertise. We've been working in this area for years. And just to give you an idea what we have done in the past, we did partner with ARM to develop this simple application that helps mute population. I'm not sure if you would be able to hear the sound on this video, but let's take a look.
No, we can't hear the sound.
Okay, so it was a simple idea where by embedding sensors on your fingertips, the ASL language can be decoded into words with NLP as an AI model, and and a mute person with speech impairment can talk to rest of the world. And that enables 70 million population worldwide. It's just one of the ideas that has helped the world, and we are continuously working with our partners. If you want to find more about AI toolset, here is the link, and we do provide DNN compiler and Arduino as an open source. So if you're an expert in that domain, you don't need our help. You can go ahead and use that. If you do need our help, do come back to us. We are also integrated in Arduino IDE. If you search for Deep C, you will find our library right there. And we have a number of distinguished features that make us unique at this time of the need to use AI and ML in several of your projects. So please do use us. And again, I would reiterate, join hands on COVID-19 apps. We are looking to collaborate with you with an idea and passion. We will provide all the software access to our employees, data scientists, and embedded professionals. We will provide guidance on firmware, hardware, and technology. And we will also help you in the development and debugging of application. Please do join hands with us. Thank you.
Thank you, Rohit. So among the panelists, we also have Rohit Sharma. You both have the same last name. Are you working together somehow, or it's just a coincidence?
No, we are not working together.
Oh, okay. Okay, then thank you for your presentation. Of course, keep an eye on the chat as people are asking questions, and also I remind to all the attendees that they can ask questions in the chat in the Zoom room, or also in the Discord channel. If you join the Arduino Discord space, there is a COVID-19 channel where discussion is taking place, and we will also read the most interesting questions and ask them to the speakers during this track and during the next one. So thank you again. I would like to invite then Rohit Sharma, also from the United States. Let me just give voice to him.
Hi, there's the sound coming.
Welcome, Rohit.
Hi.
So you submitted an application about a project entitled called First Level Cough Sound Screening for COVID-19.
Mm-hmm. Yep.
Okay, tell us what's it about. Yeah, we can see you're sharing your screen.
All right. So I'll just get started here. So hello everyone. Like Alessandro just mentioned, I'll be talking a little bit about CoSpect, a first level screening for COVID-19. So what is the motivation behind this? Sort of a symptom analyzer, something that can take your cough sound or breathing sound and provide symptom analysis, as well as an individualized recommendation. Motivated by the lack of doctors, they're becoming more full by the moment as cases spike, nearly 1 million across the globe. And so we're sort of working as a first level screening that can help the public identify their symptoms in advance, as well as get individualized recommendation for how they should follow up. So the functionality is that it's a lightweight neural network that's going to be running on an Arduino Edge device, and that can generate real-time predictions.
I'm sorry, Rohit, I can't actually see the screen you're sharing.
Oh, okay.
It's stuck on the loading black screen. So maybe you can try to stop sharing and start it again.
Okay.
It's loading. I will tell you when we can see it.
All right.
Yeah, also other people are commenting that they were not able to see it. No, it's still stuck on the black screen.
Okay.
I suggest you don't go in full screen mode. with your presentation, and you just share your presentation software window directly without going full screen.
Okay. Is that better?
No, we still see a black screen.
Can you share your slides?
Here, I can go ahead and share the slides on the chat.
Maybe okay, perfect.
Right.
If you share the slides, I can try to share them myself while you speak. So please, go on.
Okay. Sorry about that. Okay. So I'm on the third slide here. The functionality is a lightweight neural network that we're going to run on the edge device. If we have sort of something that can generate real-time predictions as to what do you have? Do you have a dry cough versus wet cough present in 60% of cases? Do you have shortness of breath present in 20% of cases? And sort of the idea is that it would help out patients identify what symptoms they have if they're not able to access doctors and provide recommendations. So three big advantages of this solution. First of all, and the biggest one, is that it is non-intrusive. Because it's automated and all, there's no chance of transmission of the infection via doctors or person-to-person contact. Second, it's scalable. So unlike medical professionals, which are limited in their number, there are only a finite number of doctors, and at the moment too, they're also very busy. This is a scalable solution. All you really need is a microcontroller that can run this edge technology. And number three, it's versatile. It can be placed in a variety of settings, whether it be individual testing or simply running in the background at a public facility, for example. So what is our status? We have our neural network getting it running on the Arduino Edge device so that it can make real-time edge predictions. Second, we've developed a simple web app for co-spec diagnosis, something that can just let you upload the files, upload files of you coughing or the breathing sound, and provide analysis on your variety of symptoms and the recommendation, your risk level, so on. And number three, we're reaching out to public facilities, including airports and hospitals. Slide 6, I have a video. I won't go through that right now, but please feel free to check it out. Simply our first version of the web app running the analysis. Slide 7, a roadmap for the future development. Phase 1 would be the mobile/web app, so the short-term solution, where we have sort of like in the web app, users can directly record their cough sound to get diagnostics. Following that, moving to phase 2, local and public facilities. If we can get this, up at local, for example, airports or subway stations where there's a high chance of transmission, and identify the high-risk individuals so they can self-isolate. That's the second phase. And third phase is sort of upscaling, continuing to grow and expand into various facilities. All right, slide 8, our next steps. What we're working on right now is testing and refining our model. So we're gathering additional data as it continues to become available regarding COVID-19 symptoms, and just incrementally building upon it and expanding its functionality. And second, we're hoping to continuing to make this technology useful, as I mentioned, starting with the web app and reaching out to local and public facilities. So what are we looking for? We're looking for people across the board, testers who can help us find data and refine our model, developers who can help us improve our model, add more features, manufacturers who can help us upscale the edge devices, business people to help contracts with the public facilities, upskilling advisors, regulation advisors. So we're really looking for anyone who's interested in this cause. We know this is a very proven technology. There've been papers for several years, over a decade, that can show that cough detection is a viable is a viable source of analysis for the symptoms. And so now we're really looking to put this technology into test, into use. We've been working on this for quite some time, and just would like to share this with the world and reach out to you all. Thank you for your time, and here's the contact email.
Thank you. Thank you for this presentation. So, if any panelist, any speaker who submitted the project in these days is in the chat and hasn't was not promoted to panelist, please raise your hand and we will identify you in the list of attendees. I would like to invite Youseff Muhammad, let's try again, from Cameroon. Can you hear us?
Okay. Hello?
Hello and welcome. We can hear you.
Okay. Thank you. And good afternoon, good evening, or good morning, wherever you are in the world. And I am really glad to join you this evening. So, yeah, so I need to share my screen, I think.
Yeah, yes, please share screen. Meanwhile,
okay.
I will remind that your speech is about your project, which is an oxygen concentrator based on Arduino.
Yes, okay. So let me just give me a minute there to share the screen. Oh, I am having.
Yeah, now we can see your face, but probably. But
yeah,
okay, you can see your.
Okay, yeah, I'm still looking for where to share the screen.
There is a green button.
Oh, it's the green button. Okay.
Yeah, with share.
Okay. Yes. Yes. Okay. So I just need. So I will just share. I guess
we can see it. Yes.
Okay.
Go on.
Okay. Okay. Thank you. Okay. So maybe a little slight modification in the title there. So it is. I will be talking about the local oxygen concentrator and the analyzer system. Okay. So of course, what brings us here is the COVID-19, which is raging around the world, and especially in the developed world. But we see more and more infections in the low resource countries, especially in Africa. And the problem, I mean, in the developed world, what we usually see is like they have a lack of ventilations. So so there is this call, like this one, to like I mean, there are calls to produce or mass produce ventilators, which would be used with oxygen concentrators in order to service the patient. But the problem that we have, especially in Africa here, is that we don't even have those oxygen concentrators. Like in Cameroon here, where I am, the oxygen are delivered in terms of tanks in hospitals. And just recently, the head of a general hospital in our capital city, he said that for each patient, they had to use about at least 3 cans of oxygen each day, and which cost roughly about around $500. Okay, and $500 for a country like Cameroon, which is poor, is a little bit much. So hence this project that we have been working for sometimes ago, which is the oxygen concentrator. So the basic functioning of this oxygen concentrator is this is a simplified diagram where we have cylinders which contain nitrate filter cylinder, which is also known as zeolite, which filters out other gases, leaving the oxygen. So connected in, as you can see here on the left, with a series of valves. So, and the compressor, which which sucks in air and passes it through the cylinders, and then it is stored in the reservoir. And we also have oxygen level indicator. So the operation of this valve is shown in according to the diagram shown on the right of your screen. So we use in the prototype that we developed, we use an oxygen sensor from from Germany that we bought, which sends us the oxygen, and then we take the signal, filters it, and then passes it through an Arduino Mega that we use in order to control the system and to display the results. So what we can see here is, so we have a series of, there is an equation that got wiped out. I don't know why, but so we measure certain values in terms of millivolts, and then we convert them into oxygen concentration. So this slide shows the overview of the system that we did, that was developed based on Arduino Mega. You can see the board on the left-hand side, and then the LCD, the display, which showing the level of oxygen, the operation. And with this system that we developed, we were able to extract oxygen between, up to around 82%, from 82% up to 98%, which is quite good. And also we can see, so this is, as you can see here, it's just something which is rudimentarily made with just materials or things that we can find here. So the important thing is this, to produce this type of system, in a week we can produce around three components, which will go a long way in helping people or sick people in terms in this time of COVID-19 crisis. And the problem, as I said, is we lack a lot of resources. Since like the sensors, we need to buy them either from Germany or from China. And so we are trying to work, trying to get in contact with our government and other government and also NGOs to fund this project so that we can disseminate the idea all throughout Africa and other developing countries. So thank you.
Thank you, Youseff. This is a very, very interesting project. So I'm very happy that you were able to present this to us. I have a few questions for you, yes, and also yes. I would like to invite everyone to ask their questions in the chat, as we have quite some time, so we have time to discuss with our speakers and understand their projects better. In this case, first off, I would like to understand how did you validate this project? Did you involve doctors in your team? Are you running tests in a clinical environment?
Yes, we worked with doctors because I am working at the university hospital where I am. So in the development, we worked with doctors in order place to validate. Before it was supposed to be used, because we had to test the before it was being used. We had to take a sample of the oxygen that was concentrated, and then test it in a laboratory. To really evaluate that concentration, and it is based on that we calibrated our system to give that concentration of that. So yeah, that's it. Okay, is there any other question? I don't know.
Sorry, I was in mute. I see Muhammad in the chat is asking you to share your contact information.
Okay.
As I think that your project can be interesting for a few other people. So if you can share your contact information either in the chat or in the presentation. Also, are you going to share this presentation as well? Other people are asking for this.
Yes, I can
or maybe a link to a website or some place where you're publishing.
Okay, I think I will share it in the Google Drive, and then I can share it with everyone.
So I would like to understand also, are you in touch with other hospitals or countries which need this kind of devices? Are you collaborating with other people?
Yeah, in terms of collaboration, I contacted some of my colleagues, biomedical engineers in certain countries like in Uganda, Kenya, but they did not get back to me. Also in Bangladesh, I think I contacted on a professor that I have been working with. Okay, so they were also all intrigued by the idea, but as I said, the problem is they could reproduce it there, but they are also looking for resources in order to do that. So the main problem, as I said, is really the resource.
I see. Geoffrey is asking, with this device, how many patients can be provided with oxygen at the same time?
Okay, we did not evaluate in terms of number of patients that can be evaluated, but the prototype you see here contains around, it can concentrate up to 10 liters of oxygen. So maybe based on that, you can imagine how much maybe each person can use, or how many patient can be served with one of these devices.
I have a couple more questions. You mentioned that you lack resources, so you can produce 3 of these devices every week. I guess you are referring to financial resources to buy the components, or there is also a problem with sourcing and shipping the components?
Yeah, those are the two actually. So the first thing is like the financial resources, and also like as I said, if you have to buy the components, you have to get them either from Europe or from China mostly. So and especially in this time where all the the airports are closed, so you might also face some difficulties in that. So those are the main issues that we have.
Okay, I have one final question. As far as you can see, do you think that the COVID-19 pandemic will increase demand for these kind of devices in African countries, especially?
Yes, of course. As I said before, the number of cases you can see are increasing. First of all, is we did not even have means to test them. That is why I guess the numbers were low. But with the arrival of the testing kits that was donated by Alibaba's Jack Ma, so a lot of testing has been done, and it's in each day, in each country, you have like more than tens of cases that are being diagnosed, and more and more of those patients will need oxygen, how can I say, therapy, or they might use to use this device. So I guess as time goes by, in a few weeks or months, we might really see this device will be very, very helpful in managing this crisis that we are facing.
Okay, so I think that your presentation in this conference could be useful in order to create connections with other people who might join efforts with you and make this scale. Okay. See more questions. There is a question from Luca Toldo, who is the next speaker. He's asking, how did you address the problem of energy storage?
Energy storage in terms of the power supply of the system, or if it is in terms of power, for now it's we use the mains power, it's plugged in and then it works. But in future, it was back when we developed this device, in future we were thinking of using alternate power supplies like solar panels or solar power, in order to service this equipment.
Okay.
I hope that that's...
Okay, thank you. I would like to invite Luca, the next speaker, as he has a few questions for you. So I think it's nice to create a connection and a deepening on this topic. But first, I would like to invite Massimo Banzi, co-founder of Arduino.
Youseff, congratulations for your project. It's very nice. So,
okay, thank you, Massimo.
So if you send us an email with your details, we will ship you some boards.
Okay, thank you.
Helping you accelerate this.
Okay, and thank you very much. And may I say that it is an honor to speak to you. I am really grateful for your support. Okay. And,
don't worry, it's our pleasure. We are grateful that you use the Arduino to build something that's so useful for people.
Okay, thank you very much. Okay, thank you.
So Luca Toldo, welcome.
Hi, can you hear me?
Yeah, of course. So if you have a few questions for Youseff before you start with your presentation, we can just steal a couple of minutes from the schedule. And
Sure. So Youseff has very interesting presentation. I've been using with patients the oxygen concentration particularly for COPD patients. So that seems to be, for me, it's an interesting use case. Certainly devices like your one are quite expensive also here in Europe. The main problem is, and their use case, as I said, is COPD. So patients which are mobile, they can walk around, they don't stay in bed, and therefore portability is an essential, it's a must-have. I was wondering, are you using a electric pump to pump the oxygen to pump the air, right?
Yes, we have an electric pump. Like
how did you resolve the problem of the noise which the pump generates? Because among COPD patients, that is a big problem.
Yes. Okay. That is something that we were not able to address at this point. Okay. What we did was to try to insulate it in a cushion, such that maybe to dampen a little bit of those noise, but it was not that good. But okay, hello. But in our research, I mean, we were thinking that maybe we could find another pump or a compressor that could produce this, that to compress the air without much of this noise.
The other problem is the kind of compression which you use. Did you measure if the compressed air had any kind of particles, or according to the compression system, there can be oil or the membrane which is doing the compressions, which could then damage the air. Did you do analysis of the air after the compression?
Okay, the analysis that was done was mostly to find the concentration of the air, but and it's just that we did not think about this, and I think that is something that we need to work with especially with the microbiologists that we are working, who tested the air in the laboratory.
Yeah, the gas chromatography and all these kind of techniques.
Yes, exactly.
You need to do GTC in order to check that the quality of the air is sufficient.
Okay.
Yeah, these were the main. So it's very valuable for single patients, COPD, which means mobile patient, not restricted to a bed, which means it's very valuable. It's heavily used here in Germany, devices like that. They usually have also smaller volume. So if you look for a smaller volume, this could also be another target for your use case. Smaller volume means easier to transport and wider usability.
Okay. Yeah.
Very nice.
Thank you.
Thank you.
Okay. Thank you.
So again,
are you going to share the drawings?
What?
Are you going to share the drawings and all these things?
Yes, I'm going to share first of all, I'm going to share the PowerPoints, and then I will try to collect all the design files that we use to share it with you.
Very good. Thank you.
Thank you again, Youseff. I'll also share your contacts.
Yes.
Welcome, Luca. Also, thank you for helping us discuss this project. You submitted quite a different project about a very different issue related to intensive care. So go on.
Here in Germany. Oh, sorry, I'm having a small problem with the sharing, but I know how to fix it. So here in Germany, so a big problem is managing, or overall in Europe, the availability of screens, the availability of resources, of beds or whatever resources across the country, particularly in intensive care units. Intensive care unit beds, which are very complex devices, they are relatively few, and they cannot. So they are very relatively few, and they are fairly expensive, and therefore it's a difficult to access them. So it's a big problem, which is here in Europe, is to know where can I go when I need an intensive care unit. Where can I go? Where is an available such a thing? So that was the reason why 2 weeks ago, together with my son, I came up with the idea of addressing this need with a very simple idea. I mean, everybody has knows about the dash, so the buttons by which you can order things, and unfortunately I'm having a problem with Zoom and not showing my screen. So
if you can share your presentation, I can share it for you.
Yeah, I'll be happy. So I can mail it to you, right? But
yeah.
And so what we did, we simply well, maybe I can show my. Can you see my? I can try to show my camera. Can you see my screen? Oh yes, you can see me. So we built this device, and with this device, it's simply there is an ESP there, a Node MCU ESP, and if you could share the I mean, I'm sorry, and then there is a very simple button, and with this button here, you can in this moment, this device has sent a healthcare information message to a central database that the device was in a status active, and this information can be seen on the web immediately, and therefore immediately it's codified according to international standard for healthcare interoperability, and there you can monitor the status of which resources are available, and these simple ideas address all the problem of identifying where are available ICUs, intensive care units, beds, or any kind of resources which one needs to have. The video, I put up a video in a YouTube. I've shared with you the YouTube link, Alessandro. If you could put that up on your screen, that would be easier. And so this, as I said, this idea consists of a simple. So meanwhile, my son made even a smaller devices where the Node MCU is on the back, and what is sorry, it's on the back. And what is also cool is that this device is also implementing a cryptographic digital signature, which means this thanks to the Arduino software environment, which you kindly provided for free, then this device also digitally signs with the RSA cryptography the message, which is then published on the public database for fast care interoperability resources, and there nobody can tap it, because the power of this small device attached to it, the easiness of programming thanks to the Arduino. Exactly. So this is a video. If you can start it, this is a called Fire EHR button. Fire, it means first RKL interoperability. Everybody can have a look on it. And here it's a true live demonstration on how one can operate the device. And then if you scroll a bit faster, then you can see basically, so in the back in the screen there, you can see the status of a database. The database is a public database according to the FHIR, which is a standard for healthcare interoperability, and that's it basically. So we did this, I did it as I mean, I'm in a software company, but I did this in my free time together with my son, which is a computer scientist student. And then basically this address the needs of identifying quickly, easily, and online there is in the GitHub repository also all the source code, the drawings. Meanwhile, my son made a new design. And yes, so this also shows that you can do digital signature in using a simple ESP 12F like this one, and that's basically that's it. This project has been presented to the German hackathon. The device is using Wi-Fi, but it has been presented at the German hackathon organized by the German government, and exactly this one. And at this page, you will see all the lessons learned from the approach, various drawings, the cryptographic aspect, and it's on devpost.com. And I'm really sorry for the screen sharing, which now didn't work due to some problem with the ZoomAs and the security of Apple, and being the first time that I use ZoomAs on this Mac. So
thank you, Luca.
That's it.
I have a question. So you presented this to a hackathon. Did you get any feedback from,
yes,
the medical authorities? I mean, there is demand or potential demand for these devices.
Right. So there is demand in China. For example, I have colleagues in China. They explained me that they collected the status of the device of the available bed by hand on paper, and then it's a very tedious and non-scalable process. Obviously, this easy device, which basically consists of a Node MCU or equivalent. I mean, I simply use Node MCU because I love IoT and I love Arduino. And I had it lying around, so that I use it. And I'm really amazed because you needed to do cryptography, you need to have a Wi-Fi, obviously, and it doesn't work. You see there in this screenshot the encoding of the digital signature down there, and it's all done extremely fast without additional stuff. So yeah, there is a need. However, depends to the country which you're looking into. For example, here in Germany, there are several thousand hospitals, and all of them, they have a hospital information system. And the hospital information system, obviously, it's a proprietary solution usually, and it has already the kind of a tracking of the bed. So the issue of sharing where are the beds is more of a business aspect than of a technological aspect, yeah. And however, this approach here with this small device, IoT Fire device, which is not a medical device because this is just a switch about availability of a resource, and therefore does not need to get standardized according to medical device regulation, which can be extremely time consuming. I've been working 20 years in a pharmaceutical company in R&D, and I know how regulations are very important, but obviously it takes time, and a grassroots activity or quick things they're needed. So such a device, as I said, can be used for rapidly. For example, if you look at the emergency situation, like are happening now in the US or in Brazil, where thousands of beds are prepared, but they don't have certainly time to track each of those beds. Obviously, one could extend this mini device with a GPS tracker or other tracking, other longitudinal, latitudinal tracking the sensors in order to have an exact on-the-spot position where is the bed available. And I haven't yet done that because obviously in GPS we know it inside a room, inside a building is not that good actually. And but obviously thanks to the good library which I have in the Arduino software development for Wi-Fi based location tracking, that is also a possibility to add on. So long story short, with this device here, we see IoT done, addressing a real need in healthcare and using the latest standard for communication, interoperability, and cryptography all on a chip. Thank you.
Thank you, Luca. Also share your contacts as people might be interested in asking for more information and collaborating with you. So we have a Discord channel, COVID-19. We have the forum. We have the Arduino forum has a board dedicated to COVID-19 projects. So that might be a good place to share also the link to your design, so that we foster some collaboration within the community, which is the main purpose of this conference.
Sure. And thank you very much again to Arduino, to the company, and congratulations to the inventors. And thanks also for the great software which you are making available for free. It's really a power nuts. It's really amazing. Thank you so much.
Thank you. Thank you also for this. Of course, please support Arduino so that we can continue developing free software for everyone and foster this ecosystem. So now let's move on to a different topic. I would like to invite the next panelist, Nastaran Hashemi from Iran. Just let me voice them. Nastaran.
Hi, I'm Nastaran Hashemi from Iran, and I'm here to present our Arduino project, which aims to combat COVID-19. Let me share my document.
Welcome. Also, we all know that Iran is fighting COVID-19. These are tough times in our country, so.
I can't. I found it. You can see my presentation.
Not yet.
Okay. No problem. I can say by my voice.
Or if you want to share the link to the
I
presentation or send it to me, I can share it while you're speaking, as you prefer.
I think the voice is enough.
Okay.
Okay.
Yeah.
Okay. I would start with a question that we all know the answer to. What happens to the body after contracting the coronavirus? As you know, COVID-19 mainly affects lungs. This disease is a respiratory disease, so the lungs are usually affected first. According to what doctors said, what we are frequently seeing in patients who are severely ill with COVID-19 is a condition that we call acute respiratory distress syndrome, or ARDS. ARDS doesn't happen with just COVID-19. A number of events can trigger it, including infection, trauma, and sepsis. But the point is that all of the patients who have COVID-19 have this condition. I want to say what ARDS do with the body. This condition causes damage to the lungs, which leads to fluid leaking from small blood vessels in the lung. So the oxygen saturation, the SO2 percentage in one's lungs would be lower than the normal situation. And this, so this factor, the blood oxygen level can be used for diagnosis, the ones who need to go to the doctor and they need to be checked. According to what WHO said, a below normal oxygen level is under 95. If yours is under 93, you are suspected to have coronavirus. And if it's under 90, you should visit doctor as soon as possible. So in this state, I should say that what our project is and how it can help the situation. We have made an expensive pulse oximeter with Arduino platform. So what pulse oximeter this is? A pulse oximeter device is a device that estimates the amount of oxygen in your blood. It does so by sending infrared light into capillaries in your fingers, toe, or other body parts. Then it measures how much light is reflected of the gases. So in this way, we can understand the oxygen level of the blood, and then understanding if the person is at the risk of coronavirus or not. This device, I mean, the pulse oximeter, is available in the world. But the problem is that one, it is expensive, and two, they cannot be used in the homes. And if a person wants to check if he or she is at risk of corona, they should go to hospitals or the places that are for testing, where is very polluted, and on that places the risk of getting the virus is very high. And three, in some countries, for example my country, Iran, we cannot import even medical devices and these oximeters because of the sanctions against Iran. If you know about the sanctions and that America has for us, they ban us from importing the medical devices, and so we have to make them by ourselves to save our lives. Then I want to talk about the technology and how we make this oximeter by only Arduino devices. We have made this pulse oximeter device using Arduino Nano and MAX 30100, which is the IC from.
Nasran, I'm sorry to interrupt you. It's just that
You're welcome.
we all would like to see something while you're speaking.
Yeah.
Also, people are asking for a presentation link or some visuals to better understand what you're talking
okay.
about. So if you have a way to share something, and then you can continue, of course, with your presentation.
How can I email, for example, the presentation? How can I share my PowerPoint to you?
Sure, I will send you an email address in the chat, and then you can resume
okay.
your speech. Sorry, everyone, but I think this will help our understanding of Nasran projects.
Okay.
Here it is.
I cannot see your. Okay.
Yeah.
I will send it to you by now.
Just be patient, everyone. We are doing this for you.
Excuse me, because of the problem. I'm uploading my PowerPoint for you.
Perfect. Okay, thank you. So please go on.
Okay. Then. Okay, the technology. Our device consists of an Arduino Nano and an IC called MAX 30100. The IC that I said is a pulse oximetry and heart rate monitor sensor solution. It combines two LEDs, a photodetector, and low noise analog signal processing to detect pulse oximetry and heart rate signals. The MAX 30100 operates from 1.8 voltage until 3.3 and can be powered down through software with a negligible standby current, permitting the power supply to remain connected at all times. The wiring and also the programming part of the. You have my voice?
Yeah, we can hear you. I just haven't received your presentation yet.
It's uploading, I think. Yeah. It's uploading now.
Okay.
The wiring and also programming parts of the device is so simple, and all of them can be found in the net. So with this IC and an Arduino, we can have a compact device that will be possible to carry out the measurements and also send the data to another device by adding a Bluetooth module. this test may be slightly less accurate, but it's very easy for doctors and people at home to perform. So we're relying on it for fast readings. You can easily build this device at your house and check, for example, your oxygen, the percentage of your blood oxygen very easily and daily. So you would not need to go to doctor or hospitals for checking or for a test. Because as what our government said, something about 40% of the people who have COVID-19 in Iran get this virus from hospitals. They go, for example, they see some signs of the COVID in their cells and they freaking out and they go to hospitals to check if they have the disease or not, and then they catch the virus from the environment. So with this simple and actually inexpensive device, which I think it would be less than $50, you would save your life, maybe. So I sent this for you. I think the message sent.
Okay, well, I will share it as soon as I get it. We have a question. Have you validated your project?
How to validate it? I just said that we have tested the device in some Iran's hospitals too.
Okay. Also, there is a technical question by Luca, another Luca, who is asking, why did you use the 30100 instead of another one, since it's difficult to procure for you?
I think I'm the speaker of the group. The technical ones cannot be speaking English, so they choose me to talk. But this module is used in medical needs in the world. I mean, the accuracy of it is very high. So the result will be better, and you can rely on the result of this module and what it said. So we choose this.
Okay. So thank you. I just got the presentation, so I will share it quickly just to let people understand what
the photo. Yeah, this is what we have made it, and the left photo is actually the IC.
Okay, so it's based on Arduino Nano. You are currently producing this in mass quantities. So
I think not for large amounts, but we have made something about I think 300 of it for Iran users for free.
Okay. Okay. Well, thank you also for this. Also, we have
You're welcome.
Ahead of a few minutes on the schedule. So I would like to invite, if they have something to say. There are two people in this chat who submitted their project, but they are still at a concept stage. They are Mario Milanesio and Luca Scandelli, who are working on pulse oximeters as well. So if they have something to say and comment, which can be useful for other people working on these projects, I'm more than happy to let them talk. So Mario, if you want, you can. Yeah. Welcome, Mario.
Ciao, Alessandro. Hi, Alessandro. I'm working on something like the previous girls. I don't remember her name, because I sent you my presentation. Can you share? Because I don't know how to.
It's not. It's probably not accessible. We need to be.
Sorry.
You need to give me permission for that.
Oh yeah, sorry. Okay. Nice. It should be public right now.
Okay, so please go on, and I will share.
Okay. My father has lungs problems from some years, from a couple of years. So he used a simple device you can find in the fourth slide. I am with my family, bought on this simple oximeter on Amazon, okay? But during this quarantine, it is very difficult for me and for my sister to get at my father's home to control if he is not so scrupulous. So sometimes he doesn't measure. He should measure every day because his oxygen saturation is not so good, but okay, 93 maybe every day. It should be 93 every day. Sometimes it raises a little, sometimes it lowers. And if people without any problems has 97, 98, 99, okay? So the problem is this for me, to have data and to control if my father is measuring his level, his saturation level. So I thought I can mix two things. I can mix my ability to send the data to Google Sheets because it is simple or not so difficult, and to join an MAX 3105 from a Spark Fun. You can find in the fifth slide, okay, to an ESP8266 or Maker 1000, Maker 1000. In order to send this data somewhere I can control. This was my problem, but I thought this could be useful for doctors because we know doctors can go. It is better doctors doesn't move from their home in order to keep away themselves from COVID. So maybe this device could be useful. I'm working on it. There are some libraries, but right now I have Pimoronis, the black one model. I think it is not so, there's not real compatibility with SparkFun library because there are some problems getting values from pulse from the heart. So I'm trying to find the bug. Okay. Next, I will 3D print a simple case, just like this one I found on the Thingiverse, but I have to modify this because I want the device to be to work on battery and with a small LCD or something just like this in order to show my father the values. So my father could use this device just like the other one bought on Amazon, but data get on the cloud, so I can see just in real time, and this could be useful for doctors too. I shared a simple instructables. I made in the eighth slide. I made some times ago, sharing data over Google Sheets. I'm using it. It works just fine. I think maybe it would be better to use some other specific cloud services, but it was simple to get back data from Google Sheets. So right now I'm using this. That's all.
Thank you, Mario. Make sure you share your project in the forum and in the community channels of the Arduino community, so that other people who share the same need can join efforts with you. Because
okay.
Also during this track, we have seen that medical devices which can help the quality of life of people affected by COVID-19 and people around them are not limited to ventilators or devices directly attached to patients, but we also need devices that make things easier, collect information, and solve a number of problems around COVID-19, also indirectly connected to that. So thank you very much. Luca Scandelli, do you want to say something quickly, maybe, since you yeah, if you want to, yeah.
Okay, I just attend the presentation because I was interesting in these things. I don't know. I just want to. I put a link in the chat where I collect some ideas about this oximeter, because I had the same issues as Mario. To check from my house other people, and here in Italy, as Mario knows, there are not so many nurses or physicists that can go to the houses and check the patients, the people, and as Nastaran said, there is also the possibility that going to the hospital, they become healed. So I just had the same idea. But my problems are where to procure the sensor, because everything is delayed due to the logistics, and this is one point. And while the second point that I wanted to suggest, if you access the link, you can see that you can even map with OpenStreetMap and UMap the level on the map, the level of the concentrations, so one nurse can I don't know how to share the screen can see in real time the situation of many say 10th, 100 patients. It depends on the situation in your country, and in real time see what happens, and the fastest route to go there and intervene if there is a real problem, if the oxygen level goes below a level.
Okay, thank you very much. There is a big interest around these projects. They are needed almost everywhere, and so I really encourage you all, Mario, Luca, but also see that Luca Toldo is commenting with technical questions about security and other technical choices. I invite you to work together in the Arduino forum.
Can I also make
yeah, Massimo.
To make a quick suggestion, because I've been looking into this topic for another project, and I would suggest that you look at the AFE 4490 from Texas Instruments. So basically, it doesn't include the infrared sensors. You have to provide infrared LEDs yourself, but it is available from a number of distributors right now in reasonable amount, and there's a number of simple design examples that you can build. So AFE 4490, exactly that one. Check it out. There's even a company I found which sells the clip with the cable on it. They are a bit expensive because they are replacement parts for actual machines. So they cost about 90 euros, but you can get the full thing with the sensors and the cable and the connector. So, what do you mean? Sorry,
Great.
why somebody says, please stop him?
No, he is not referring to you, Massimo. Don't worry. There is some noise in the chat. But anyway, so we have a few minutes left. I would like to invite the last speaker, who is Miguel Fernandez Rodriguez. Just let me enable him. Welcome, Miguel.
Thank you.
From the Spanish maker community.
Exactly. Let me see if I find how to share the screen.
There is a green button.
Yeah, share. Yeah, of course. Okay, so this should do it. Let's see. Okay, so
we can see it.
Okay, let's see if I press F5 if you still see it. You still see it?
We do.
Good. Okay. Thank you. So I present myself. Basically, I'm Miguel Angel. As Alessandro said, I'm working at the University of Barcelona, and I'm working with the coronavirus makers. And we are basically, this is a little bit far. That's why probably I'm the last speaker, far from the Arduino, because here we don't have Arduinos. But I think that is also very important, and I hope that you agree with me after the presentation. Basically, it's about masks. So basically, open hardware, surgical and filtering masks. We've been basically developing different kind of solutions, and as you can see here, I hope that you can see my pointer. So basically, this one here is basically done with a coffee filter. It takes only 2 minutes, and this is kind of like the standard mask that everyone should have. Like this is the equivalent of the social distancing. This is something we should always wear right now. On top of that, probably you are aware of these very creative and very developed 3D printed masks, in which basically the problem is that we don't have the filters. So one thing is about the safety of using the 3D printed masks, and the other one is basically that we don't have right now a lot of stock of filters. So in itself is a challenge. So basically, as I was getting calls from basically hospitals that they were running out of masks, even in the ER room, then basically I started to search for anything that I could make for them. Then I got this solution that is called the Boston model. It was developed in the Boston Children's Hospital, and this is basically like the last resort thing that they can use the physicians in the ER room. This is really interesting in the sense that the ventilator filters, as this one, that probably all the people that is reading about the ventilators and the respirators, you are aware of this kind of filter. This is available. This is available in any hospital right now, and even the production chain is open in all countries. At least even in Spain, where we lack a lot of other things. So this one is open, and we have resources around this. The problem is about the anesthesia masks that you see here, because this is something that takes time to do, and also it is not done in so much quantities. We are never prepared for a pandemic, and then basically we wanted to give this solution, something that can be used instead of the anesthesia mask from the community. So for this, basically we develop with a team, of course, involving physicians and involving designers and so. we came up with this one. So it looks very ugly, but everything there has a function. And what you can see is basically that with this one, you can already put one of these HME antiviral filters, the kind of filters that I was just explaining in the last slide. But also we are developing these for being modular with these other kind of filters that still there is some stock. It's not like there is a lot, but still there are like tens of thousands, for example, only in Spain. Everything we develop is of course open source, is open hardware, and then you can also download the models and everything in the GitHub link that you have here. Then here you can see basically this is the prototype in FilaFlex. So basically this is flexible, but this is not the way to go for ER rooms, because the FilaFlex and every other additive manufacturing, you know that there are some defects and some tolerances, and there are also even the issue of porosity in the micron scale, which I will talk in the last slide. But it's kind of very negligible in a low risk scenario, like for example, I don't know, like a police or in a supermarket. That can be good, but in a ER room where the density of viruses in suspension, because they are aerosols, they are colloids in suspension, is very high, so there is not an option to take any risk. So this is only the prototype, and we need to move for injection in rubber, in silicone, or any other material like this. No? So here you can see the proof of concept. So, one thing that many people is not aware of is that this kind of filter is already prepared for sustaining the breathing of a patient. So basically already has the ability to work as a filter in a mask. Of course, this needs to be done in collaboration with the medical workers, but with the physicians, because they are the ones that are going to use it. And if they are not basically trusting the design behind, there is no point that we are doing it. So we for sure need the input from physicians. We integrate them in the developing team. We need to go for validation. Homologation, maybe we need to do the full homologation, but at least a validation, because again, this is a very high risk environment in ER rooms. So we need to go for those tests. We really we need to quantify how much this mask is isolating from the viruses outside. It's not like we want to avoid that, but we are asking the government to take it easy in the bureaucratic part, and of course maintain all the rest of all the tests. And then, of course, one thing that I need to stress is that this is only possible if we locate and mobilize all the local industry around the injection, or even in the hospital supplies and so for locating where these filters are producing in your country. And the last slide, sorry, here. It's about I don't know, probably you are not aware, probably you are, but basically the additive manufacturing has a problem, and this is on the web already. It's about the pores. So basically the claims is that it's not easy and it's not safe to use additive manufacturing for pieces that are going to be as a filtering mask. And the reason is that indeed, when you take a look on the first layer printed on this is PLA, then you will see this kind of holes. This probably you don't see clearly, but this is the scale bar is 10 microns. So here we have holes in the range of the less than 10 microns. But of course, the virus is 60 nanometers to 140 nanometers. So there's plenty of room to go through. But the masks are not done with only one layer. They are done with several layers. So if you do the maths, in principle, as you have many layers with random pores, then it's very negligible that you have a connected path that the virus can go from one layer to the next. Again, this is something negligible in the case of low risk, like in the street, but we cannot take even this risk in the ER room. So one solution is basically that we can coat it with any polymer. And for example, it could be that easy as coating it with Vaseline or with any um, cream that is not water-based but oil-based. And this is the same picture of the same kind of PLA media, but then in this one it has a PEG, polyethylene glycol layer on top, and then you see that basically it seals all the pores. And another route, it could be basically to do this kind of acetone vapor baths for ADS, or you can use THF for PLA. But this needs to be done in a very controlled way. So I would really recommend to do this only in more developed facilities like a fab lab or something like that. But again, you can see from these two SEM images that this is before the treatment with the acetone bath, and this is after. And then you can see here that the first layers are really shielding from outside, and then you don't have any more the pores. Again, I would really recommend to go for injection always in the ER room, but also consider that there are other ways that you can make the 3D printing safe also in this kind of harsh environment. I think that's it. Thank you.
Thank you very much, Miguel, for this project. Although it's not it does not involve electronics, it was still important to feature this in this conference, as many people in the Arduino community are also working with this kind of 3D printing projects, and yours is very well thought, and your experience was very important to share with other people. So thank you, everybody. Thank you to our speakers. This track ends now. However, in a few minutes, we will move on to the next track in this room, which is dedicated to technology and manufacturing challenges. So we will also have the speakers and the guests that attended the other track about ventilators. They will also come to this room to talk and discuss how to move from a concept to production, to mass availability of this project. So technology and manufacturing challenges. We will start in a few minutes in this room. I didn't mention this, but in room 1, another track is starting dedicated to legal and certification challenges. So we really encourage everyone every representative of a project to invite another team member so that they can attend both rooms in parallel. Good evening, everybody. So we are starting again. We are going to start this final track of this conference. In this room, we are going to talk about the technology and manufacturing challenges. How do we go from a concept or a prototype to mass availability of the projects we are discussing today? In the other room, so room 1, you will find the YouTube link on the website. There is a track dedicated to the legal challenges, so certifications and related topics. So if you're interested in that topic, go to room 1. I am happy to present our colleague Dario Pennisi, who is responsible for hardware development in Arduino. Welcome, Dario.
Ciao, Alessandro. Hi, everyone.
Dario is here with us as an expert, we can really say that, of manufacturing. So you can ask questions to him about all your concerns regarding manufacturing and especially sourcing parts, which might be not easy as usual during these tough times. Dario.
Yep. All right. So shall we start with the questions, or may I go through a short presentation that I put together?
I think you can start with your presentation. That could serve as an icebreaker.
Mm-hmm.
And meanwhile, people are free to post their questions in the chat.
Oh, of course, yes. I think you have to stop sharing. Thank you. All right. So let's see. So first of all, a short summary of what's happening around. Maybe everyone of you already figured out, but the impressive thing is that the virus has gathered the community around a common enemy. And this is impressive because there are a huge amount of projects, mainly for ventilators. And there is it's very hard to track them all. It's impressive because most of them share, let's say, a common ground in terms of the architecture and so on, but some of them have very interesting approaches. And most importantly, some of them really tackle the aspect of making sure that components are available everywhere and so on. So that's really key for this. The other important thing is that I mean, there is a need for a lot of other stuff other than ventilators. And some of these are oximeters, temperature sensors, position tracking, and stuff like that. I mean, let's not forget that before getting in intensive care, there are a lot of things that we can do. And it's really important that we think about how to handle that. So that is really the last resort. So, of course, one of the suggestions I feel to make to everyone which is willing to contribute is that, I mean, hospitals are lacking places in the intensive care, and at least in Italy, where, as you may all know, we had a very bad situation. Although things are recovering, we still have a lot of issues. And although it's always possible to try to create an hospital in 10 days, like in China and in Italy, it's not really the solution. So most likely people that is being affected is going to be treated at home. And so I would encourage everyone willing to do something to think about what can be done for people at home that is sick and can be treated, can be somehow followed remotely and things like that. Also, keep in mind that designing a ventilator might seem the nicest thing in the world, but that kind of equipment is very dangerous. It can kill people. So that stuff very likely needs to be certified, and medical staff should be somehow comfortable with that. So it means it must have sort of, a medical proven interface. Also, it's very important to have a look at what you can do, as I was mentioning before, getting to the last stages of this virus. And so it's really important, and probably a much larger scale problem, tracking contagion and checking symptoms in the very early stage. Now, there is a problem in terms of the kind of problems that of the kind of approaches that the two sides of technicians are taking. Medics, on one hand, know very well what to do, but they're lacking very likely engineering skills. They may go wrong on the kind of sensor selection or on the kind of motor or the power supply, the software development, and how to, let's say, make sure that all of the stuff that works together is reliable. At the same time, engineers very often read the specs and think they know everything, but they don't know what is really required from the medical perspective. And I have seen a lot of projects where basically people has designed things and then just at the end thought about looking at medical specifications for that kind of device. And of course, one of those big issues is the hardware failsafe. An engineer usually thinks about adding a lot of sensors, a lot of closed loop controls and stuff like that. But actually, we all know that things can break. And it's very important to have hardware failsafe, because as it was very clearly stated in the other session, basically, if you put too much pressure or reduce the pressure too much, you are going to kill the patient. And again, we are engineers. I am one of those that like to add as many features as possible, and we always end up overcomplicating everything. So let's keep it simple, stupid, right? Let's keep it, let's say, manufacturable, the least possible amount of parts, the most easy to source. I mean, think about the fact that there are places where very likely motor controllers, but even ambu bags are not easily available. And this kind of shortage will increase with the demand and with the fact that even logistics is a nightmare today. Couriers are not delivering anymore. And of course, one last thing is, everyone talks about Industry 4.0, connectivity and so on. Keep in mind that hospitals usually don't like having wireless. Wireless is not something that is considered reliable. And so, I mean, if you have to connect your stuff, think about wired, possibly, and think about the fact that every data that you take out of a medical machine is sensible data. And there are, at least in Europe, very strong laws preventing this information to be distributed. Now, the very interesting thing is that in these days, there have been a number of initiatives which shared links for complete designs or requirements for ventilators. And this is very interesting because the first link is probably the most interesting, because that is the full design of a medical unit that has been approved and actually is in production. So it is very important to have a look at that, because that really brings a lot of information. The other interesting thing is the UK government actually shared a very detailed say specification list for what is required and what is optional. So that is really something you should have a look at. And And finally, there's a lot of, let's say, projects which are doing a very good work in sharing their roadmaps, their documentation, and so on. And I encourage you to have a look at those. So the bottom line is our community is made of makers, and we love to do stuff ourselves. But when we talk about medical equipment, we have to think about three very important things. First one is redundancy and reliability. So first of all, this should not absolutely fail. If it fails, then there must be some safeguard, something that allows the hardware to, let's say, prevent the patient to be harmed. And of course, if you have a sensor, probably you need at least 2 or 3 because something can break. Remember that ventilation means moving air in and out probably 1 time a second, or I mean, 1 time every 2 seconds. So there is a lot of stress on every mechanical part, and this should be up there for quite a lot of time. Also, it must be solid. I mean, as makers, we are usually happy when we have a lot of wires hooked up and somehow have it working. But in this case, there is a very important aspect, which is this equipment, especially if it's going to be in an hospital to treat a patient which is in critical conditions, must be easy to clean, must sustain liquid splashes, and by liquid splashes, it can be anything. I mean, it can be vomit, it can be blood. I mean, we're talking about people that is really sick. And then approvals. I mean, it's very important that if you start something, you already have on your roadmap clinical trials on animals and humans, and you know how to handle that. Because, I mean, if you're not getting there, don't even start. There are a lot of other things that you can do that are needed and which are very useful. So let's try to keep the efforts concentrated on the few things that really are working. So in terms of manufacturing in volumes, let's say that you planned everything, you designed everything, and now you want to manufacture. There are a few things that you have to take into account from day 0. The first one is design for manufacturing. What this means is that you have to, first of all, make sure that the components you select are available and will be available from the supply chain that you're selecting and that you have at hand. This is not really trivial because if you just look at distributors without talking to anyone, you may not know that some components are going to be end of life, for example, or that they are just available as a limited stock after which you have 14, 16, 20, 50 weeks of lead time. So it's very important that you talk either with the silicon vendor or with the distribution to make sure that those components are and will be available during the production lifetime. Secondly is the manufacturability. Very often designs are full of connectors, harnesses, and many different parts. So this means that the manufacturing the system, not just a board, will become very complex, and it will take a lot of time and will make also the whole product probably a bit more critical. So a review on the design, on the basis of the design, is really, really important. And finally, you have to make sure that testing, production testing, is also not an afterthought. If you deliver something, you want this to be working, and you have to make sure that, I mean, every unit has the same features of the one that you validated. So not only you have to test as much as possible, but you have to make sure that the coverage is high enough to make sure that every device that you ship is compliant. And then finally, when you completed the testing, then you have to make sure that, first of all, all of your devices are, let's say, all of the components required to assemble the devices are available through your supply chain, and the delivery is working, because I mean, you can manufacture a lot of stuff, but then you have to deliver. And this means making sure that the couriers will bring goods in time where it's needed. Keep in mind that there are areas which are under lockdown, and so you may need to have special agreements with governments and with couriers to deliver in particular areas, especially the ones that are most affected. And finally, I mean, since shit happens, everyone knows about it. Even if you tested it very well, something may go wrong, or the user may have trouble operating your device. So you have to make sure that you have means to support your users. Again, we are talking about thousands of infections and thousands of ventilators, and maybe hundreds of thousands of people ill. So we have to make sure that there is a structure behind whatever you are designing that is going to be able to support whoever is using that. So what we are doing in Arduino is, first of all, well, we opened immediately a page under the Arduino website, COVID-19, where you can get information about what we're doing, what is our level of operation, and about the events like this. And we also added a very important link, which is Contact Us, where basically we are asking you to contact us directly if you have a critical project for which you need a large supply of boards, so that we can make sure that you get what you need. Of course, if you see stock around, you can order that. But if you talk to us directly, we can make sure that, first of all, that the quantities you need are stocked for you. And if those are not in stock, we can get you the lead times. And also, we can provide you personalized quotes based on volumes. So we understand that, of course, our prices are based on single pieces, at least on the stores. So if you're talking about tens of thousands of pieces, then of course we are very willing to help you. And finally, not least important, I am committed to providing hardware and firmware design support to whoever is something relevant. So feel free to contact us either through the forum or through the forum we have on the Arduino website, or via Discord, or whatever means you wanna, and you wanna reach out, and we'll be happy to support you as much as possible. So finally, I'll try to show you a small comparison, because most of the designs that we have seen so far are more or less based on the same products. So right now, the products which are mostly used are the nanos, because they are really low cost, and they provide more or less whatever is needed for small PLCs, which is more or less whatever is needed for a ventilator, a simple ventilator. So let's say nanos, unos, and mega are the most used ones. Mega probably is the one that has been more, let's say, interesting for the more complex devices, where people is using multiple motors or multiple sensors. So of course, this the design, the board you choose is basically heavily depending on the complexity of your design. And although we are not yet shipping it in volumes, we are also advising some people for advanced designs to use Portenta, which is our latest brainchild, which is designed for, let's say, more complex applications. It has high-res graphics with DisplayPort and so on. So on that one, of course, we are not recommending it to everyone for the simple reason that is quite different from the usual Arduino designs you're using. But I mean, if you think you have the need for that, and especially if you are planning to use something like a complex user interface and so on, maybe this is for you, because that will help you in designing something which is robust, industrial temperature, and will last for quite a lot of time in very extreme temperatures as well. All right, so that's more or less it. So I hope I didn't take too much time, and I'm waiting for your questions.
Dario, you will not wait too long, because we already got a number of questions during your presentation. So
okay.
Robert Reid, who was one of the speakers who introduced this conference, is interested in what you said about not using Wi-Fi. He's asking, what are the issues with wireless, and can we count on Cat5 Ethernet instead?
Well, actually, I'm not an expert on medical environments, but it is my understanding that it's preferable not to have any source of radio frequency close to other medical devices. Even if, I mean, you know that this kind of stuff is somehow, let's say, certified not to be affected by that. That is, of course, something you have to take into account. The other important thing is that wireless is not that reliable. I mean, anything can happen. Someone can come up with a high energy RF source, which is disturbing the communication, and you don't really want to be affected by that. Unfortunately, the Wi-Fi uses a free part of the spectrum, so anyone can transmit there, and it's very easy, unless you have a very strong infrastructure, to be jammed by other transmissions. So, of course, Ethernet is much more robust because it is absolutely under control. And other than that, I mean, there are a lot of applications which are still using serial ports or other wired communication.
Mm-hmm. There's another question by Robert, which probably tackles the main concept building these projects. Are some Arduinos in greater supply than others?
Well, that's a very good question. We are trying to prioritize the requests, and the last slide I showed is basically already sort of an answer. So we are prioritizing the nanos, which are more or less the most requested, the unos, and the mega. Those are the ones that have been mostly used in, let's say, 80% of the designs that use Arduino. There are some other fancy things, but we are trying to steer everyone on the same boards so that we can limit the kinds of boards that we manufacture. At the moment, we are not seeing capacity problems, but of course we need to have some planning. So whoever has a real project and it's somehow willing to go in production soon, we can plan it in advance.
There is well, there is still some discussion about the connectivity topic. Robert is asking, will clinics have wired Ethernet?
Actually, we do have some Ethernet shields for Uno and Mega, and we have Ethernet on top of Portenta.
So these are the boards supporting Ethernet.
Yes.
Yeah, the product recommended for Ethernet connectivity. I would like, well, while other questions are flowing, I would like to while we collect the questions, I would like to ask you, I know you attended the previous track about ventilators, about Arduino-based ventilators. I would like to ask you, What are your impressions after hearing that long list of efforts by the community in terms of technological challenges? What still need to do, and what level of maturity did you see?
Well, actually, there's really a lot of designs, and we have seen some of them being pretty mature. Some of them are already in experimentation on animals, and soon will be on people. So I have very high hopes that very soon, at least some of these designs will get used in real life. As I was mentioning, the most important thing is that let's say these designs have been thought of with different goals in mind. Some of them are using very common parts, and that's very interesting because those can be easily replicable. I think that one of the issues with that kind of concept is that if you do an open design that then can be assembled by anyone, I think the issue there is that you may end up having no one manufacturing it. I mean, if you have this community creating something, then probably you have to also make sure that that community has people around the world which is ready to manufacture that following a very strict procedure. So let's not just keep this, let's say, 1 inch from the end. Let's try to think about the whole process. And that's my message to everyone which is designing something, not just the ventilators, because as I was mentioning, there are very big pitfalls waiting for you on manufacturing, on logistics, and so on. And I think it's really, really important because it's very easy to fail here. I mean, for example, we have shipped boards from Turin, from Biella to Turin. The distance is 40 minutes by car. And it took 10 days because the courier was not actually able to deliver them because they were overwhelmed. So that's exactly my point when I was talking about the supply chain and the delivery. It's really critical right now.
Dario, so far we talked about the very hardware part and manufacturing. What are your thoughts about also the safety issues? Speaking of software, I mean, is there any good practice you would recommend in terms of, for example, decoupling the logic of these devices, splitting interface from core functionality, in terms of best practices we can tell to our community?
Yeah, actually, there's one big thing that let's say works very well with newcomers to the programming world in Arduino, which doesn't work very well in some of these applications, which is the loop thing. So basically, the Arduino software structure is mainly a setup and a loop, where basically you are supposed to have a big state machine doing things. In reality, there are libraries that allow you to do sort of multitasking, and those are, let's say, the things that make things a bit more complex, because basically, usually you want to have on the same board the logic that drives, let's say, the application, and then some logic that displays the user interface or that handles the input and so on. So in that case, it's a bit tricky if you don't handle things correctly, because you may end up screwing up the core logic if you spend too much time, for example, updating the user interface. So that is really something that needs some attention and some good profiling. And at the same time, it's also one of the reasons why, let's say, we thought about Portenta, which is a dual core where you can have two separate processors doing two completely different things. So you can have Python running on one side and Arduino running on the other. So with Arduino, you do the low level, and with Python, you may do, for example, the user interface.
These are advanced hints for developers, but since we are talking about critical devices, they are not never advanced enough.
No, I mean, the real problem here is, as I was mentioning, also redundancy. So, for example, a good design might be to have several boards, not just, let's say, processing boards, but also sensors, and make sure that you read all of them and have triple voting. So, for example, if you need to measure pressure and one of the pressure sensors may break, then you have to have three and say get the most likely value out of the three. The same happens for the mechanics and for the electronics. You may want to have two different boards, one driving the application and one driving the user interface, unless you have a dual core processor like this.
And what about power supply? How critical is that part? Is there a risk of not putting enough attention on that topic?
Yeah, one of the lessons that I learned while trying to support some of these designs is that it's a bit hard to understand how much force you need to compress the ambu bag, or I mean to send air into the lungs of a patient. And because basically the amount of resistance you get varies quite a lot depending on the patient. So the amount of power that you have to give to the motor is very high. And I've seen projects where they started with a small motor and with a servo actually, and then they migrated to very big stepper motors or let's say linear actuators. So let's say that first of all, over designing in this case is a very good practice, and you may want to have of course a very big motor driver and a very big motor so that it can sustain full day operation. I mean, this is something that should work 24 hours a day with the motor, which is almost working every time for the full time in both directions. So there's, I mean, a lot of reliability issues there. And of course, the power supply must be able to sustain this. Don't just assume that it's good enough, measure it. I mean, if you think that you have something which is close to the limit, measure the power supply because it may dip and may cause unwanted results.
Right. I think we will get back to the power supply topic because I see some debate in the chat. But I also wanted to ask you about the MKR boards, since some people are asking about them, and since I see quite a bit of interest about connectivity. The connectivity topic is raising depth. So
yeah, it is my fault actually. I should have mentioned it. So of course, among those boards, we also have Maker Zero, which is also very interesting. So it's somehow a basic board which has a Cortex M0, the same that's on the Nano IoT. And the interesting thing about the Maker is that the family allows you to change to swap the board, having a different kind of boards with Wi-Fi, Bluetooth. Depending on what you are looking for, you can get the board of your needs. And of course, over that one, we also have shields for Ethernet, for CAN, RS485, temperature sensors, thermocouples, whatever.
Yeah. Well, meanwhile, I see that Sherman Chen is commenting on your thoughts about redundancy, and especially mentioning the Portenta, which is one of the values of the Portenta is in having the possibility of this kind of redundancy between the different cores. So this is something that well, looks interesting for our
Yeah, let me
audience.
also add that the other interesting thing about Portenta is that it also has two kinds of crypto chips. So if you really, really want to send data to the cloud and you're allowed to, you can use very strong security by storing certificates and keys into these secure elements.
Right.
One of the two.
While you were not in this room and during the previous track, we were talking about pulse oximeters and collecting data from pulse oximeters to the cloud, especially to monitor elder people remotely. And people were commenting about security of this data transfer.
Yeah, absolutely. There's a huge issue. I mean, of course, you can think that storing a password in your code is robust enough if you protect your code in the microcontroller, but actually that's not the case. Unfortunately, you have to think about the fact that the world is more and more connected, and thinking about the fact that this data might seem useless is just a mistake, because there's always going to be someone looking for some additional data for improper usage, and that will affect you. So think about security even before you start thinking about IoT.
Right. There's a question about Portenta. Is the Portenta USB power delivery compatible?
Yes, it is. We support power delivery. However, keep in mind that Portenta is 5 volts only. So what it does is it negotiates the amount of current it requires, but it doesn't use power delivery to, let's say, let the source generate higher voltages. We are also able to source power from Portenta if needed, also because Portenta has DisplayPort output. So one of the applications we have is connecting USB-C to a hub with DisplayPort output or HDMI output, along with USB hub and things like that. So that really becomes like a laptop that you can connect with a keyboard, a mouse, and a traditional display.
Oh yeah. No, there is a very technical question, but I'm not sure. We can pretend you have a complete answer, but what protocols do medical devices typically use? What logic levels are typically used?
Okay. I don't think I have those kind of answers. What I know is that there is an open standard for data exchange, which is called DCOM. And I have been designing some stuff based on that. I only know partial it. So I don't really have an answer. But if you look for DICOM, you can check there, and there is at least some data about how data is exchanged between medical devices. I'm not really sure how data is eventually exchanged between devices in terms of control. I have no idea.
Right. So other people were discussing the redundancy and the decoupling topic, and there was this very technical questions, but interesting for developers. Is it recommended to apply FSM rather than schedulers to trigger tasks in Arduino Uno and Mega? Maybe if we can provide some context about this question, because I'm not sure that everyone understands this.
Absolutely. So the question is, assuming you have an Arduino, as I was mentioning earlier, you have a loop function which is called regularly. So the first thing to remember is that it is called regularly if you exit regularly from the loop function. So for example, if you use a blocking function such as, for example, moving a stepper motor, then remember that, I mean, you cannot do anything else while the motor is stepping. And the same applies for other blocking operations, such as driving a NeoPixel or things like that. So it's really important when you have a state machine that you time exactly what is happening, and you take into account for errors. Because, for example, if you have an I2C cable and you have an I2C device, you have a long cable and there is some noise or something, then the device might reply with a not acknowledge, which means that you have to retry the operation, for example. So instead of staying into that operation for a short while, you may stay there more than expected, and you have to take that into account. So you have to have timeouts, you have to have now a number of countermeasures to make sure that the maximum amount of time you spend into each step is properly measured. On the other side, if you go for multitasking with a scheduler, there are two different ways of doing that. With a cooperative scheduler, you are able to switch tasks when you give control to the scheduler. So again, things are not ever happening in parallel for real. They are happening only when you are, let's say, not doing something useful, so you're giving control to something else. And there is real multitasking, which we are able to support on some of the new nanos, which run embed and on Portenta, of course. But that also poses a number of other issues, because multitasking means that the same processor executes different things sequentially, but you think they are happening in parallel. So you have to take into account that while you're doing something, you might be interrupted and resumed slightly later. So, for example, you cannot pretend that timings are really, really precise if you're using multitasking. And that's one of the reasons why we started Portenta, which has two processors. So if you really want to have something very timing, let's say, with very precise timings, then you can run it on a dedicated processor. That's really the whole point.
Right. All right. I would like to pick up this question that was asked, not about electronics, but still it's a technological challenge related to COVID-19 projects. What is your opinion on designs that use many 3D printed parts? 3D printing is fairly slow. Would it be too slow for mass production of large quantities? I would like to give my opinion, but also to hear yours, Dario.
You are the 3D printer wizard, so probably you should answer that. But I can give you my opinion, which is probably totally wrong. First of all, never underestimate the community. Actually, I think that there has been a lot of discussion about those 3D printed adapters for the face masks from Decathlon and other makers, other manufacturers. And basically, in Italy, the organization that designed them asked the Fab Labs to ship over printed parts, and actually that happened. So, I mean, 3D printing may be slow, but don't underestimate the power of the community. My concern about that is really a bit different. It may happen that, for example, you may have faulty parts due to the fact that some 3D printers have less precision and the layers may not stick very well. So the part might not be, let's say, replicable too much, and may not be able to sustain the pressures and the mechanical stress that is involved with these kind of devices.
I totally agree with your points. Basically, the effort in designing and refining a project should be in reducing the amount of 3D printing material, for example, by using readily available parts, for example, fasteners, for example, laser cut plywood or other kind of plastics or other kind of materials that can be manufactured or sourced more easily. So it's a compromise. However, as you said, the power of the community and the distributed manufacturing is demonstrating that there is a lot of potential manufacturing capability that is being exploited. For example, in Spain, there are local communities organized in local using local Telegram chats so that they can spread the requests to the local chapter who is able to manufacture locally. And this is something that can be really exploited if there is a good reason for this. So going back to electronics and software. I think we have seen during this conference that a number of communities are developing projects putting a lot of attention on the mechanical part. However, you also in your presentation you mentioned how they should work on the safety of the device, also from the software point of view. But I think it's not enough to tell them take care of that part, because I think all those people are doing their best. Is there something we can, some hint, some good practice we can tell to these community projects so that they increase the level of maturity of their projects, even if they don't have the resources, the skills within their team?
I guess that here the point is probably the reason why we started this conference. I was really surprised to see so many designs that look so similar but are so different. And of course, it's very important to have differentiation, because you may invent something maybe if you work by yourself for a while. But the power of working together is really what makes the difference. And if I look at the projects that are around today, some of them have hundreds of contributors. And that's really where things start to fly, because of course, you may be naive on a topic, but you may be an expert on something else. And when you start discussing topics with other people that have different experiences, then you create a knowledge which is bigger than the sum of the knowledges of the participants. And in particular, I think that the amount of knowledge required for such a device is really huge. And for example, looking at the specifications that you get from the UK government, you get a glimpse of what's needed. But if you look at the design from Medtronic, that is really key. I mean, it's really, really interesting, because they are mapping the requirements of the software and the hardware to specific medical requirements and directives. So you not only know that something is needed, but also why. And I mean, as in any cases, I mean, you need to study a lot. Don't pretend that you're the smartest guy in the room. I mean, you have to look for knowledge for everything that you don't know enough about. So consult with medics. if it's a medical device, consult with medics. Read the documentation and make sure you understand that. That's really the point. And consult with a lot of people.
Right. Very, very important hint. We have a technical question. Do you have proper recommendations to shield the boards against EMI?
Wow, that's that's difficult. All right, so if you want to avoid EMIs, first of all, you shouldn't need to shield the board. The first thing you need to do is design the board so that it doesn't emit that, and that is really, really difficult. First of all, it really depends on many different aspects. For example, if you are designing a board which has high-speed clocks, then very likely power supplies are going to be the main source of EMI, because I mean, you have the clock, which of course is critical, but usually that is a very short trace and doesn't have any problem. But what happens is that inside the chip, everything is running at that speed. So the current that goes into the power supply is actually oscillating slightly at that frequency. So that's really where the problems are. So you have to design your power decoupling very carefully. and you have to make sure that there is really no ripple. I mean, if you see ripple on the power supply, that means that you're actually very likely emitting EMI. In addition to that, connectors, cables, those are the places where signals take off in the air. So basically on every interface, you have to put, of course, ESD protections, which are needed to avoid frying the board when someone, let's say, touches the board with a charge on it. And of course, you need to have high-speed inductors to prevent internal frequencies to be transmitted over the cables. And then, I mean, if you really did everything right, but you still are emitting, there are different ways to shield the board. There are conductive paintings that you can spray within the box. This is a very expensive solution, but works very well for artisanal products. And otherwise, try to use as much as possible metal boxes, metal shields, and so on.
Well, this was an important topic. Yes, and the person who asked the question is saying that appreciated your answer.
Thanks for the question.
I would like to invite the speakers of the panels who are attending this one to comment or to share their thoughts, since they actually went through these challenges while making their prototypes. So if they have something to do, just raise your hand and we will bring you in the discussion. So you were mentioning in your presentation that Arduino is also available to support these communities with design help.
Yes.
And people are asking in the chat more information about what Arduino is doing on that front. So.
Well, first of all, I am personally discussing with some of the teams. Of course, it's going to be impossible for us to support everyone doing, let's say, every sort of hardware. So we are trying to somehow give the best possible answers through the forum, for example, and following up with the groups which have more medical relevance directly. So for some of them, we wrote some code. For some of them, we did some design reviews. For some others, we are just, let's say, helping them in, let's say, selecting sensors or sourcing boards and things like that. So, I mean, we are trying really to do whatever is necessary, whatever is required to help. We understand that, I mean, the biggest issue really is not, in my opinion, the design. As I was mentioning, the designing and making sure that the product work is probably half of the journey. The other half is, let's say, manufacturing it, testing it, and delivering it. So I think we are still in the early days, and everyone will see a lot of trouble in front of them. And I mean, we are also willing to help with the sourcing of the components if needed. Of course, again, we can't do everything for everyone, but if there is something relevant, we are very happy to help.
You mentioned testing, hardware testing, and I'm thinking that, well, we know that Arduino can be used for a very wide range of purposes, from learning, education to industrial grade applications or professional context. In between, there is a lot of a big variety of potential applications. I think that many people are actually moving from simpler applications to more professional applications using Arduino. So testing a prototype is a key part of making a reliable product. what suggestions can we give about properly testing an electronic product, which is it's a combination of an Arduino board and other components all together, and what is the correct approach to properly test this kind of product?
Well, first of all, I want to hijack your question, adding also the concept of validation, because there are two aspects of testing. The first one is validating the design, and the second one, of course, is testing during production. Very often you get problems in manufacturing because you didn't validate properly the design, and you didn't figure out that something can vary enough that the product goes out of spec, for example. So it's very important to make sure that when you start a design, you have a validation plan and you have a clear idea of what you need to test, what you need to measure, in order to make sure that what you are designing is really compliant with your expectations. As I was mentioning, sometimes, for example, I was mentioning it during my presentation, you may assume that something is working just because from the high level perspective it works. So you try to tell a motor to rotate and it rotates and you're happy, but then maybe you connect a load and it doesn't rotate anymore, or it gets some dust and it becomes harder and harder to rotate and it doesn't work anymore. And maybe you're guaranteeing your system to work for 1 year in extreme conditions. So validation is really, really very, very important. And then testing is also very important, as you were mentioning, because you have to make sure that the manufacturing process allows you to replicate the same level of performance of your validated prototype. And this is a really key point. I mean, as Arduino, we have been famous for having very reliable boards, and that's something we are very proud of. We manufacture them in Italy, not because Italy is better than anyone else, but just because of the fact it's close and we have all the process under control. And in addition to that, we test our boards very thoroughly. I have a guy who's really getting crazy with this. And the interesting thing is that as many other people is doing, we are testing Arduino boards with Arduino boards. So we are putting together a test system, which at some point we plan to open source, which is going to be used not only for testing during manufacturing, but also for continuous integration. So this is an effort that we are, I think is a bit overdue, but we are working very hard on that because we want to make sure that the quality of our code improves. And we want to make sure that whenever someone contributes, the library is tested against all of the hardware it claims is compatible with.
So I was scrolling the chat since there are still some questions. There is a very practical question about power supply. Is there a good solution for unstable power supply from like a 12 volts car battery?
Okay, I don't think that a 12-volt car battery is unstable. Actually, it's probably one of the most stable things you can think about. What is really unstable is the voltage when you have the cranking. So when you turn on the engine, and that's because basically the engine requires a lot of current from the battery, and when the engine starts moving, the battery starts to get charged. And that, of course, creates all sorts of noises and spikes on the power supply. So, of course, if you are designing something which is supposed to be working during, let's say, cranking, then good luck. There's a lot of work there. But other than that, let's say, car batteries are huge, so they act like the biggest capacitors in the world. So, I mean, you shouldn't get any instability there.
Right. I think this kind of this person who asked this question says that they want to use a battery to solve the 110 volts power supply problems. So we need a circuit to charge the battery while using power.
Yeah, I mean, for that, you can actually buy off-the-shelf chargers. Usually, you can find some DC-DC converters, which are basically LED battery chargers, and at the same time, they also provide you with the power. Basically, they are sort of UPS systems. So they provide you with 12 volts, and these 12 volts are automatically switched between the battery and the power supply. The battery is continuously charged, of course, and there is also controls for overcharge, undercharge, and so on. So I would say just use those. They are sold almost everywhere on Amazon and so on. The problem is eventually sourcing them, but right now, but it is common components, I would say.
Mm-hmm. There is a question I'm not sure I fully understand, but no, okay, I see that Massimo already answered. Massimo Banzi already answered in the chat about availability or the need to manufacture these DC converters, which are actually available in the market. We are reaching the end of this track, but we are still here for a few minutes in case there are more questions about manufacturing, about sourcing parts, about how can Arduino support the communities fighting COVID-19 on the technology side. Yeah, the recording of this session as well as the entire conference will be available afterwards on our YouTube channel. Also, we will be reachable through also in our community channels. So if you go to Arduino forum, you will see there is a COVID-19 board dedicated to these topics. So the discussion continues there, and also in our Discord channel dedicated to the pandemic response by the community.
Alessandro, let me just answer that question about the sourcing. So, of course, it's going to be very difficult for us to support smaller communities. We are always there to respond to forum requests and so on. The real problem with sourcing components right now is that you have to take into account the fact that either you have really relevant, or basically you have to think about the fact that there is someone which is trying to, let's say, solve very big issues and needs prioritization. So for example, in Italy, we had a lockdown which forced all of the companies which are not strictly related to the medical supply chain to stop, basically. So, I mean, you may say that this is unfair because your project is the most beautiful in the world, but you have to think about the fact that, I mean, it's really difficult. As I was mentioning, couriers are having trouble delivering everything. And Amazon, for example, started stopping the delivery of some kinds of goods because they want to make sure that who really needs something gets it. In any case, if some relevant projects needs help in sourcing parts, we are really close to silicon vendors, and we are happy to make connections to make sure that you design in the right parts and you get them when it's needed. As I was mentioning, we have this form. Please fill it in, get in contact with us, and we'll make sure that we address your questions as fast as possible.
Dario, we are collecting the final questions. I wanted to share with you a thought I have seeing what the community is doing as a response to the COVID-19 pandemics. I see that many people are using the well-known Arduino boards for their projects because everybody knows and loves the Arduino Uno and the well-known Arduino Nano. However, for many applications, as you mentioned in your presentation, there are boards that are probably better suited for these applications. I mean, the Arduino families are much more
bigger, yeah.
big exactly than the Arduino Uno and the Arduino Nano. So I would really like to invite everyone to go to the website and see all the ones you mentioned in your presentation. So the new Nanos, the MKR boards, which are several boards with different connectivity offering, the Portenta, and all the families, and actually reach out to us and ask whether anything is not clear, because there might be better options for your projects than the default choice.
Yeah, let me add something very interesting. I mean, of course, everyone loves the what we call the hero products, Uno, Due, Mega, Nano, and so on. However, we really worked hard to evolve and to give our users a better experience, more features, and so on. And the one thing that is really outstanding is that you can run almost all of the libraries on almost all of the boards. And that's really important, because most of the times, whatever code you wrote on a board can seamlessly run on anyone else. And that's really important, because if you run out of pins or if you run out of resources, there's always another bigger board that can suit your needs. So, I mean, I gave you a list of boards that can be used as preferential, because we are prioritizing them in this period of difficulty for the logistics. But if you look at our catalog, we have really a huge amount of products for every possible application. So I really advise you to check it out.
There is an important question. Will the Arduino factory be open to keep up with demand? Because we know that many manufacturers of boards are not able to ship. There is a bit of uncertainty about supply chains. Maybe it's important to stress what Arduino is doing in terms of supplying and keeping up with the demand.
Yeah, absolutely. And I mean, we are collecting, and if you have more information about that, please do that. We are collecting letters from the various groups that are doing important things with us, also to demonstrate our government that in a way we are essential for the development of this equipment. So they are with us. They know that we have been doing a very good job in supporting people. And so basically we have a particular status in Italy which allows us and our supply chain to stay open regardless of the various decrees that are stopping everything else. Now, of course, we are trying to do that for a limited number of products. So you may see shortage on some of the products that I didn't mention, for the simple reason that, of course, we have stock. We are still manufacturing something. However, we are trying to give priority to all of those products that are in higher demand for critical designs. So I'm not expecting to have huge trouble because our production capacity is quite high. But there might be, of course, some delays if things, of course, continue like this.
And if you go to our website, there is a COVID-19 page, which is up to date. We keep updating it every day. So you will see the current situation of the distribution network of Arduino, the resellers, and our direct contacts. So if you are in the need of, as Dario said, of a large quantity, especially for medical reasons, you can reach out to us because we can help you understand how to source these parts in the most reliable and the quickest way. So I think we are done. I don't see any more questions. Well, so I still invite you to come to our community channel, the forum and Discord, to share your thoughts. And thank you a lot, Dario.
Thank you.
Your presence was very well appreciated by our attendees. We should do this quite more often. So thank you to everyone. And let's continue talking, because the emergency response needs makers, needs engineers, needs open source hardware and software, and needs our collaboration. So this conference was our contribution to this worldwide collaboration. Thank you, everybody.
Thank you.